Next type of solving is still going to be with exponentials, but instead of having one that's an exponential on both sides, we're going to have one that only has one exponential part to the entire equation. So we're going to start really simple with ones that are very short, and then we're going to kind of work our way up slightly in difficulty with a few more steps. I have a little checklist here, kind of what the process is. Isolate the exponential, meaning get it by itself. Oftentimes, like the really simple ones, they're already isolated. You're going to use logs. So we know exponents and logs are inverses, so they undo each other. If I have an exponent with base 5, then I'm going to use a log base 5. They always have their counterpart. I am going to show you a button on the calculator that you may or may not have found. A lot of times students kind of find it on their own when they're messing around to evaluate a log that you don't know, or you can use the change of base formula, but I do want to show you the calculator button to make it a little easier for you. And then finally solve for x. You will probably get decimals more for these problems than you did for the ones that we just did and some of the ones later in this topic. So to start the process, I'm going to start with this one right here. It's already isolated. So when I say take the log of both sides, what I mean is on both sides, you're going to take the log of the same base that you have the exponent base. So we have log base 2 of 2. The reason you're going to do that is all of this will cancel, leaving you with just the x. Your log base 2 of your exponent base 2 are inverses. They cancel. On this side, you're going to have log base 2 of 7. Here's where you have a choice. You can use that change of base formula that I taught you in a previous lesson, or I want to show you the calculator button. If you go to your calculator, so make sure you have your calculator out and close, or pause this video if you need to grab it. You're going to go to the math menu, and you're going to scroll all the way down until you get to letter A. So it starts with numbers, and then after 0 goes to A. If you hit enter on that, it will allow you to put in any log base, any number. So I want to do log base 2 of 7. So this is another way. Some of the calculators, the older ones, didn't have this feature, so change of base was more important. The newer calculators have it, and it can be a nice time saver. So we get about 2.81. Next one, same idea. We're going to take log base 4 on both sides, because it's currently base 4. So the log base 4 of 4 will cancel. You'll be left with just x. On this side, you'll have log base 4 of 15. And we're going to use that same calculator button. So we're going to go to math. We're going to go to A, or you could actually go hit the up arrow and go that way. It's a little faster. We're doing log base 4 of 15. And we get 1.95. So those are the really, really easy ones. The ones that are a little more involved have more stuff with them. You can't take logs of individual parts. I've had students that'll say, well, I'm just going to take the log of every single thing here. You can't do that. You have to isolate the exponential first. So what I mean by that is you have to subtract 4 first. So you get 10 to the 2x minus 3 equals 17. Now you're going to take the log of both sides. Now, since this is base 10, it's just going to be the common log on both sides. This will be even easier on your calculator. Common log or natural log are the best because they have a nice calculator button. So the common log and base 10 will cancel. You'll be left with 2x minus 3 equals the log of 17. We can go to the calculator and just type in log of 17 since it's a common log. We get 1.23. We're going to add 3 to both sides. So I'm just going to, on my calculator, hit plus 3. And then we're going to divide both sides by 2. So you can kind of just keep working with the calculator. You get 2.11 or 2.12. So again, got the value of my calculator, added 3, divided by 2. Next one, same idea. I'm going to add 3 to both sides to get rid of the minus 3 because I want to isolate the exponential. I'm going to take both sides log base 6 because I want to use the same log base. The log base 6 and the 6 cancel, so I'm just left with x. And here's where I want to use that calculator button again. So I'm going to go to math. You can use the up arrow to get to it faster. You're going to type in base 6 of 13, and you get 1.43. My last two are just slightly messier, not too much actually. So I'm going to subtract 3. So I get 5 to the x plus 2 equals 22. Take both sides to log base 5. So we get x plus 2 equals log base 5 of 22. Calculators needed. Go to math. Go to this log. They just call it log base. Log base 5 of 22. And then whatever we get to get x by itself, we're going to minus 2. So my answer is negative 0.08. And then finally the last one, add 5, 7 to the x plus 3 equals 13. Take both sides to log base 7, log base 7. So we get x plus 3 equals log base 7 of 13. Calculator, math, log base 7 of 13. And then subtract 3 to get x by itself, you get about negative 1.68. You're going to get a lot of decimals for these, so just kind of be aware of that. I think on Delta Math, let me take a look here. I think on Delta Math, they do expect decimals. So here's an example of one, and it will tell you to round to the nearest hundredth. I think a lot of them will have that in the directions. Yeah, around to the nearest hundredth. So you need to isolate the exponential. Like for this one that you're looking at, you would have to divide both sides by 237. Then take the log of, in this case, base 2. Use a calculator. It's going to make it so much easier. And then that'll allow us to solve for x, and you will get a lot of decimals. So that is how we solve an exponential that only has an exponential on one side of the equal sign.